Hi everyone, it's good to be here in person in front of all of you. My name is Drew Banin. I'm one of the co-founders at DBT Labs. I've done a lot of presenting over the past couple of years, but actually first time in person on a stage. It's a little bit easier on Zoom and a little bit less bright too. So I want to talk about DBT and Python, and I want to start with a bit of a primer on DBT and kind of what DBT is all about. So just quick show of hands. Has anyone here heard of DBT before? Okay. Great. So this will be a recap, the next couple slides. The company's DBT Labs, the product's DBT. There's a sort of open source component, cloud SaaS component too. But we're going to keep it high level, at least for the beginning. So DBT is all up in your business logic. The big idea is simple questions like how many active customers did we have yesterday begets these other questions like what do you mean active and what do you mean customer and what exactly do you mean by yesterday? So DBT is all about sort of transforming this data in your data lake, data platform, into a format where you can answer questions like this a lot more precisely and correctly and quickly. The other thing to say is DBT is all about this ELT paradigm. So we don't really extract and transform data. We'll kind of push all of this down to the data platform. So DBT generates SQL queries that create tables and views. And in this way, you can sort of transform from this sort of bronze quality data through to silver and gold, I guess in the Databricks parlance, to get these like abstractions over your data that you can then like plug into data science and BI and other use cases like that. The other big thing to say about DBT is that it's sort of inspired by the software engineering workflow. So you're going to version control your code, write automated tests, document everything, and have a sort of CI/CD workflow for deploying it out to production. When we started building DBT about 6 years ago, we saw a lot of people writing SQL queries in folders on their desktop, and it was just like hard to collaborate. It was like a single player game. So what we've really tried to do with DBT is make it more collaborative by leveraging these software engineering principles. So this is sort of the canonical diagram that we used to talk about DBT. On the left, it's sort of all this raw data that lands in your data lake. And that's good data, but you can't actually plug it in directly to your BI and data science and ML use cases because it's like dirty. And so DBT is the sort of tool and workflow that you would use to develop these data models in SQL, test and document them, deploy them out to production. So again, just like kind of a look at ELT versus ETL. I think the biggest benefit of sort of inverting this model and doing all the transformations in the data platform is that you get a lot of flexibility. There's like no such thing as a free lunch for any of us, but storage is really cheap. Like computation's pretty cheap anymore. And so you'd actually, I guess in our experience, prefer the flexibility of getting to change your transformation logic, like update your business logic as your business and products evolve, versus the super cost-effective model is actually really rigid and inflexible. And we find that like time to value is worth a lot. And again, storage is really cheap. So ELT is sort of where it's at for DBT. So this is sort of a DAG of DBT transformations. On the left-hand side, we're going to have these green data sources. This is stuff that gets loaded into the data platform. And then all of the blue nodes in this DAG are transformations. So this is actually like our pipeline around our headcount OKR. So we're growing like pretty aggressively at DBT Labs, and we track how many people we've hired and sort of conversion rates through different parts of the hiring pipeline, right? So these are all models on top of different lever data sets. And on the very right, there's a teaser of this new concept in DBT, a metric. I'm actually not going to talk about that today, but if you find me after, I'll talk your ear off about it. So from data sources through transformations, metrics, and you get this whole lineage kind of out of the box if you use DBT. When we think about DBT, if someone says like, what is DBT? The easiest answer is like, we do data transformation. The reality is like a little bit more complex than that. There's all this work around data quality, data documentation, and it's not really just transformation. It's really, we think of it as like creating knowledge about your organization, kind of through the code that you write, the business logic that you're encoding on top of your data. But in a word, we say data transformation. It's a little bit quippier. So historically, this data transformation happened all in SQL. So we love SQL. It's accessible, it's powerful, it's scalable because it runs on a sort of remote execution environment, not on your laptop. And the big idea with dbt is that as a user, you write a select statement. So you're defining some sort of transformation. And then dbt will kind of wrap that in all the DDL and DML to go off and create tables or upsert data into tables. And it can do that in a sort of database-specific way. So dbt has connectors to Databricks and every other data platform you can think of, plus a whole suite of open source connectors too. So because it's SQL and it's all pushed down, the data doesn't leave the platform. You're bringing computation to the data rather than bringing the data to the computation, which for like intensive workloads is sort of the winning approach, we think. This is the bigger thing though, and it's sort of what I want to talk more about today than just the transformation part. We say that in addition to transforming data, dbt transforms teams. So anyone ever heard the purple people slogan? If not, we think of these two different types of people in an organization. You've got the sort of red people that are out in the business. They understand the marketing context or the clinical trials or the sales operations and why things are changing in Salesforce. But then you've got the blue people. And these are the people that really get the technology. So they understand data platforms. They can write code. They get version control and why it's important. And what you really need is a bridge between these two worlds. So we call these the purple people, which I think is a great name. And specifically in the kind of dbt universe and the modern data stack, if you will, we call these folks analytics engineers. And we call the work analytics engineering. So it's people that really get the technology, they really get the business, and they can be that bridge between the two. So ultimately, like, we think this actually results in better work done faster. You get velocity and quality. And the way that you achieve both is through this collaboration, right? You're getting people that can write the code and really understand why they're writing that code. It's not like the throw it over the fence, ask a data engineer for a CSV kind of workflow. It's like you're empowered to do it yourself. So empowerment's like the #1 word I would use to describe what effect dbt has in the world, right? So in a world without dbt, we find that data engineers become bottlenecks. They don't want to be bottlenecks. They're fulfilling a service. And they need to go out and get data for these data analysts, right? But the analysts don't really enjoy waiting for data engineers to prioritize their work. And I imagine the data engineers hate being inundated with 1,000 requests for data sets without the context of why they want this data and how exactly they're going to use it. So nobody's really happy on, actually, you know what? I have a pointer. Nobody's happy here. That's terrible. You don't want to be there. Whereas dbt, on the right side, it's about empowerment. So you get the data analyst more plugged into the data itself. They do a lot more of this data engineering, data transformation work. And the data engineers get to occupy this higher leverage position. So they're working on the data platform. They're doing observability and managing SLAs and thinking about data integration. They're not like fulfilling tickets to go grab CSVs from some API. Like, that's low leverage, and it's probably unfulfilling. So truly, you can break the bottlenecks through collaboration. And the way that you do that is by getting analysts to write code and use version control and collaborate using the tools of the trade that the data engineers have sort of already mastered. So I'm going to kind of back up and talk about languages a little bit more. I did say SQL. There were like quite a few dbt users, or at least folks that were familiar here. So I didn't get any tomatoes thrown at me. But historically, we've been kind of all in on SQL in dbt. This is a typical dbt model. So this is transformations on top of GitHub Stargazer data. So the number of stars on the dbt GitHub repo. So this, when we think about data modeling, this is like a pretty typical example. We changed the name of the repo from dbt to dbt core. And people can both star and unstar and then star again a repo. And we don't want to count people twice. And this is just like a vanity chart of stars in the repo. It's not business critical, right? But it's kind of fun to look at. So we're renaming some columns. We're filtering. And then crucially, this is kind of the secret sauce of dbt. This source function here is a templating language called Jinja. And the big idea is that dbt can compile this to an actual table name in the data platform, right? So this is kind of the magic of how dbt builds lineage across sources and models and how we paint that kind of lineage graph that I showed earlier. So really powerful. If you compile this code and run it, it'll actually get templated out to a place in the data platform. And then you wrap this in create table as or create view as, something like that. And that's more or less how DBT runs. So yeah, again, this is kind of the lineage graph. And this is built from the green edges, or the green nodes with the edges are sources, and then kind of model references beyond that. It's the big idea. OK, so it's all SQL. It's always been SQL. I think it's OK. SQL's great. Like, it's powerful. It's accessible. It's easy to learn. It's been around for 4 decades. I think SQL will outlive all of us. And on the polar opposite end of the spectrum, could not be more different, Python, which is also great. It's also accessible and powerful, easy to learn. It's been around for only 30 years, but it will also outlive us all, right? So like, why is there this divide? Why are there some workloads that are restricted to Python if you're doing data science and machine learning, but then BI and analytics is all SQL? It's like never the twain shall meet, right? So it's different worlds with different users, different tools, different workflows. And there's like, I think, a real gravity that's pulling these things together. So Tristan, my co-founder at the keynote yesterday, actually stole my thunder. Years ago, this was actually almost exactly 5 years ago, Tristan wrote this blog post, why doesn't DBT support Python? So back then, if somebody asked us a question once, we would answer it. If they asked us a question twice, we would write a blog post. So there's like 10 of these 3-paragraph long blog posts on our blog that's just like the answer to the question, right? It's actually cool because it's a time capsule. And you can go back 5 years and understand kind of the state of play back then. So Tristan writes, SQL can by itself accomplish a majority of analytical, non-data science workloads. Fair statement, but a pretty big caveat, right? Like non-data science. OK, that's like a lot of the work that people in this room are doing, I imagine. So it's a big caveat. What's changed since then? Well, there's gravity, I think, leading to a sense of convergence. So check, this is a high-tech animation here. OK. There you go. So let me go back one. Yeah, please clap. So, OK. I think this is so powerful. And I think it's actually incredibly cool. There's a sense of convergence, not just in languages and capabilities of data platforms. It's really about the types of problems that these data platforms are looking to address, right? So improvements in the data platforms ripple out into improvements in data tools. And it results in more choice and flexibility and tooling for analysts and engineers and data scientists. Like, this is sort of the fundamental, it's the same arc that we saw in like web browsers, right? Like, you're writing an HTML page in 1998. It's a terrible experience. Today, like, create React app, you've got like, you got an app going in 5 minutes. So more powerful kind of baseline tooling and platforms just, they ripple out into the whole ecosystem. They kind of up-level the things that we can all do and the velocity with which we can do them. So I think this convergence is a really good thing. So what do we take away from this? The fact that Databricks has invested so much in SQL. And I was really excited about the Spark Connect announcement from yesterday. So the sort of client-server model, making it even easier to run Spark code in different contexts. Plus, we're seeing a lot of other data tools that historically were SQL only, moving more towards Python and data science and machine learning. So that's the kind of convergence that we're thinking about here. Big takeaways, I think, are that data tools, like people like us building DBT, we need to prepare for the polyglot future, right? You can write code in SQL. You can write code in Python. You can write code in R, although that one's not on the roadmap yet. And we can assume that people are going to use the best tool for the job, and they want to switch between them kind of within the same experience. They don't want to use different tools for different languages. You want to use like the same kinds of tools. So teaser, Python support for DBT. I'll talk about that more in a second. But for kind of the data people in the room, like not the vendors, but the data engineers and scientists and analysts, again, it's the same message. Like, we've got to prepare for the polyglot future. And again, it's not really about the language. It's about the workload. Like, in the same way that we saw analysts going from Excel to SQL and version control, like, I think we're going to see this arc continue. And we're going to see data analysts doing the first mile of data science. Like, if you need a regression, why throw that problem over the fence? you can do it pretty readily these days in these data platforms. And so I think it'll serve to shift everyone up the stack. And I think that it's the exact same change as going from the Hadoop HDFS era to what we see on Databricks these days. Like, you can do so much more with so much less. I think we're going to keep seeing that progression unfold. OK, so I have a big reveal. We're adding Python support to DBT. Woo! Yeah, OK, great. We actually opened the first pull request for this earlier today. If he watches, shout out to Jeremy and Chen Yu, I think, on our team. Jeremy's the best. He would have been here giving this talk, but he's in Marseille, which sounds awesome. So we're adding support for Python models to DBT. I showed you a SQL query earlier. It's kind of a similar idea. You write Python code, you return a data frame, and then DBT can materialize that in your data platform. Planning on launching this around October. Want to plug our Coalesce conference. Y'all should definitely tune in online. Would love to have you in person if you're able to make it. And so if you're interested in this kind of thing, would love your help with beta testing, love feedback. And this will be like sort of fundamental Python support in DBT. So it'll manifest as PySpark on Databricks. Snowflake recently announced Python Snowpark support. And GCP, we're kind of exploring serverless Spark too. So this is like core DBT functionality that will manifest differently in different data platforms. When we think about like, why do we want to do this? Like Tristan wrote the blog post, why doesn't DBT support Python? Like, what has changed in the past 5 years? I think the big difference is that you can run in a sort of more client-server model your Python code or your Java code. And it's like dispatching SQL from your SQL client to go run on a database. Like, I'll show you this demo in a second. But you really don't need to set up your environment to run PySpark or have a beefy GPU to crunch the numbers locally. Like, all of it happens remotely, like 100%. So it makes it a lot easier to get started. I think it, again, creates the environment where you can collaborate across data science, data engineering, data analytics. Like, folks can reuse this modular work that they're doing. And again, the goal there is just like creating consistency. Like, solve the problem once. Don't solve it 3 different times on 3 different teams, using the best tools for the job. OK, time for the demo. Let's see. Before I do that, this is a DBT project. And I have 2 models in here. So let's look at both of them. This is a Python model, brand new. We'll kind of start at the bottom and work our way back. So fundamentally, this is the experience of writing a Python model. Can everyone see this OK? It's a good size? Yeah. Cool. This is what it feels like to write a Python model. You've got, oops, not that. You've got your configuration. So in this case, materialize this as a table. You can materialize it incrementally or as a view. And then you just need to create a data frame. However you do it is your business. But if you create a data frame and return it from this special function called model, then DBT will go ahead and materialize that kind of in DAG order. This one, I have a funny story to tell you. When we started the company, I had business cards that said, Drew Banin, co-founder and data scientist. I'm not a data scientist. I'm like the farthest thing from a data scientist. But I thought it sounded cool back then. So this is my attempt at data science. What I've done is I've downloaded all of the agendas, like the abstracts from the Summit website, and then do some cleanup of all the words in there. And then I've built like a sort of Markov chain of a corpus of like all the text. So is there a data scientist in the room that can come up here and explain what a Markov chain is? I'm just kidding. Big idea is you have like a prefix and a suffix. So it's these pairs of words. And so if your corpus looks like data accessibility is, then you have data and accessibility is as like 2 different pairs. And you can generate text from these pairs of words. Kind of the big idea. So I'm using this corpus to generate, I think, 100 pitches based on the abstracts for this conference. And then we're going to stick them in the table. So yeah, generate 100 of these pitches. This is a DBT model. And so I thought it'd be funny to just take the generated pitches that have a question mark in it, and we'll generate like a new title for our next talk at this conference, which hopefully ends in a question mark. Now the funny thing is, this is going to make for a good demo. Like, I don't know what's going to happen. It might be terrible. So we'll see. So let's run it, and we'll take a look. Any Vim users in the house? Mm-hmm. Woo. OK, so I'm typing dbt build. It's going to take a little bit, but what's happening is we're taking this Python code, we're running it in Databricks, and again, we're just going to create this data frame. dbt's job is to materialize that data frame as a table in Databricks. And then there's going to be a SQL model that is built on top of it. So actually, while this is running, I want to show you this, which is sort of like the very simplified view of lineage between these two models. So this is like, to me, this is the perfect picture of collaboration. It's like I've got Python stuff happening in PySpark. It gets picked up by SQL modeling happening in SQL. And this could be two different people with two different workflows and areas of expertise that are actually collaborating in the same repository and building like a unified DAG of all their work, right? I think that's a really cool thing. So we'll come back here. This was successful. It took a cool 25 seconds. I guess we were crunching too much data. So this is the fun part. I'm going to run this, and we're going to see some pitches. Data engineers, database architects, machine learning, and Thursday. Give it up for Thursday. Woo. Data to share our original hexagon and businesses with temporal intermittencies. That's pretty cool. What's the NLP classifiers? That one actually sounds legitimate. Let's find one more. Data with building blocks, better treatment outcomes. I mean, who's not on board for that? So this is pretty cool. And let's see, are there any questions? So we built this model, agenda questions. Let's select from it. The last time I ran this, there were actually 0 pitches that had question marks. Data engineering concepts, basic SQL and working on Kubernetes, our ML factory. That's kind of fun. So that could be a pitch idea for next year if anyone's looking for one. All right, so future, what's ahead? Again, planning on launching this in October, at least kind of the first version. We really think this is a multi-year arc. So very excited to integrate with Spark Connect when that's live. A lot to do in integrating with kind of all the different data platforms in myriad different ways. But we look at this as the first step in like a pretty long journey of dbt support beyond just SQL. When I think about like what do I want to get out of this, truly, I am not a person that could, like I'm pretty technical. I've written a lot of Python code in my life. I could not set up the full stack required to issue this Python like PySpark code against Databricks in a day. Like I'd have to think really hard about exactly how to do that and the platform around it and all of it, which is fine. It's like important and hard work. But I think that all the platform innovations that are happening will result in accessibility and collaboration. Because actually what you can do is punch in your Databricks credentials, type dbt build and press enter, and you've got Python models, you've got SQL models, and you've got a full DAG that can span the data engineering, the data science, the machine learning, and the BI and analytics too. So accessibility, collaboration are key. It's not that running PySpark is brand new. You've been able to do that forever. It's that DAG that's accessible to people that aren't data engineers by training necessarily. So I think that's pretty exciting. I think it helps shift everyone up the stack a little bit. OK, lost a bullet point there. Some of the sort of exciting things that we're thinking about are, how do we bridge this world between Python and SQL like even deeper, right? So can you define a Python function and have that become a UDF that you can call from SQL? Like, what if you could unit test that Python function with like the actual Python unit test library? And what if that sense of unit testing played into the data quality checks that dbt already knows about? So really just like trying to think about how deeply we can integrate these two technologies together. I think the more seamless you can switch between them, the better the experience will be. And then kind of other stuff, like could you write doc strings for your Python functions and have that show up in the dbt documentation? It's broadly like we want it to feel like writing Python. We don't want it to feel like writing dbt code necessarily. Like you're writing Python, dbt is sort of the framework around it. As we've mentioned, excited to use Spark Connect. We have a pretty interesting way of running this on Databricks today. But but Spark Connect, I think, is the future for this kind of thing. And it'll be really great when you can run this Python code from many, many different tools, just kind of like how we demoed a second ago. That's actually all that I have. We've got about 10 minutes left together. So if anyone has any questions, or if you want to like profusely applaud, now would be awesome. Thank you all so much. So yeah, any questions or thoughts or anything like that?
On one of the slides,
We're going to get you a mic, yeah.
on one of the slides, you said that the new thing is running it PySpark in a DAG.
Yeah.
But that you can do it now. Can you just maybe point me to how that works?
Sure, yeah. So really it's like, oops. Like this DAG is kind of the DAG I'm referring to. So having these models in DBT where one is Python code, the next one's SQL, you can pick up Python again after that.
Right. But before we put in the DAG, is it possible today to run PySpark? What I interpreted, I might have missed.
In DBT?
Yeah.
No, you like could not run any Python anywhere with DBT.
I might have missed.
Yeah. So I guess what I wanted to call out is like, right, running PySpark isn't new, like in the universe. Like people have run PySpark before, I guess is the point. Yeah. The new thing that we're excited about is making it more collaborative and accessible in like the DBT workflow specifically, because you could never do that historically. No, it's a good point. Thank you, good question. Yeah. Can you create a DAG within the Python code?
Meaning I want to chain multiple data frames, and be able to process.
Oh yeah, totally. So you can write really any Python that you want here.
And would it show up in the lineage?
Well, that's the challenge. So each model is sort of its own node. So if you want to write a bunch of different functions, and this is one of the other things we have to figure out, is sort of like importing functions across models. We need to find a good answer to that one. I think we'd want to leverage that kind of thing. But when I think about a model, it's like all these models are discrete objects that show up in the data warehouse. So you'll want to create one model per object, and then and those can be in a DAG. But within a DAG, it's sort of self-contained is the idea. I'm sorry, within a node in the DAG, it's all self-contained. That's what I meant. That's a good question.
My question is more about the testing part.
Yeah.
So unlike software engineering, data is all about, like the testing is slightly difficult, I feel, because of the data quality.
Yeah.
So does DBT has some framework? It's not about just checking integrity checks and all those things in the schema. It's about data quality as well, right, when you do stuff. I mean, I don't know if there is a framework that you guys are coming up to see that quality is maintained. Or
Oh, absolutely. So DBT has supported what we've called data tests like for years and years. There are definitely these sort of schema tests, so uniqueness, referential integrity, enumeration of values, things like that. But really any query that you can write in SQL, you can use to validate an assumption about your data. So you can say the sum of this column should equal the sum of that column, like across two different tables. And then you can write these really rich, so like credits and debits should be equal. It's like an example. You can encode that kind of logic about your source data and about your models. And then DBT can run these checks constantly to make sure that the new source data that's arriving conforms to your expectations, and all the code that you're writing also does not regress any logic. Do you feel like that answer your question? Yeah, right. So the nice thing about sort of going through the software development lifecycle flow and merging through GitHub or GitLab to get code into production is you can set up checks. You can sort of have reviewers that say, if you add a new model, you must test it, you must document it. It's like, why don't engineers write bad code in production? It's like, well, sometimes they do, but usually you have someone sort of making sure that it conforms to expectations. Yeah.
Hey, you mentioned Snowpark, and I think Snowpark is kind of interesting because the approach that they went is they basically are writing a translator of data frames to SQL. Whereas like you are not doing this because of the Databricks stuff. You want to use PySpark directly.
Yeah.
Did you guys think about like building this like assembler instead, like more like Snowparky style of doing it because you guys are SQL first and like really good at SQL?
It's a really good question. We, as much as possible, want to push all of this down to the data platform. Like, the code runs in the data platform. The data doesn't leave the data platform. And so I don't think we ever considered I don't think we ever considered writing our own sort of library to translate data frame code to SQL, run it on different environments. Like, that's a big undertaking. We're growing pretty quickly, but we don't have quite that many engineers yet to spend a couple of years on something like that. But we think that like the platforms will become multilingual, I guess, in this way. Like, we do see serverless Spark on GCP showing up. AWS has their own couple of tools that can help in this way, but not super well integrated, at least not yet. So as much as possible, we just want to leverage the capabilities of the data platform, and every improvement that they make shows up in kind of the UX of dbt, I think. Cool, maybe like if there's one more question, then I'll let you all get on your way.
Will we be able to use Python macros as well, or just in models?
Can you write Python macros?
Yeah.
That's a really good question. I would like for you to be able to do that. It ends up being a question of like, where does the Python run? And we actually want like 100% of this to run on the data platform, not like on your computer, not on the client. So the thing I'm really excited about is instead of macros, like UDFs, like write a Python function, use that as a UDF. I think if it's a macro, we sort of need to run it on the client to compile your code. You know what I mean? So I think we have to figure out exactly how that works, but it's definitely a topic of investigation for us. OK, yeah, sure.
So the traditional like dbt paradigm of having these ref functions to build lineage and allow you to build in your development environment, is that going to apply to Python models?
Yeah, absolutely. So right, the goal is have it be kind of indistinguishable across SQL or Python as a model. So you can test Python models, document them, run them in dev or prod. Sort of everything you would expect about a SQL model, we want to apply to a Python model. So yeah, if you do dbt run in dev, it'll build that for you in your dev environment. Did that answer your question, or did I miss?
Yeah, I'm just wondering if that workflow is going to be consistent between building models in Python versus SQL, whether you have like a long lineage model SQL-based models.
Yeah, absolutely. If I actually knew how to write PySpark, I would do more demo work, but you can take my word for it. Yeah, you can totally interleave this DAG, Python to SQL to Python. The really cool thing is if there's hardcore data science, machine learning stuff happening in the DAG, like you don't need to run it on your machine. It all runs remotely. So you can either like omit running that model, or you could actually run it as a part of your DAG, but you don't need to like concern yourself with what it does necessarily. It can just be like an input to the stuff that you're working on, or it picks up after you've sort of prepared data, just say. So that's exactly sort of when we think about collaboration and accessibility. It's like it can actually be in the same code base, and you can run all of the code, even if you don't necessarily understand like all of what it does. Cool. Well, thank you everyone so much for coming. It was fun talking to you. Thank you. And